Okay, the last step for protein synthesis is translation. So, na-discuss na natin yung DNA replication as well as the transcription. So, for today, we have translation. This is the process wherein the mRNA codon is translated or deciphered and a particular protein molecule is being synthesized. Okay, so the substance needed for translation phase of protein synthesis are mRNA na discuss na natin to. tRNA, we have known that tRNA will be the one transferring the amino acid, okay, during the protein synthesis. So carry niya yung hinahawakan niya siya magde-deliver ng amino acid because of the direction of mRNA na merong nagko-contain as nagsiserve as blueprint na nagko-contain ng mga genetic information. We know also that amino acids are the building blocks of protein. So, importante sila sa protein synthesis. And kinikarry sila tinatransfer sila ng tRNA. Now, ang didiscuss muna natin before we proceed to the translation part is the ribosomes. Okay? We also had the different enzymes. Na-discuss din natin to in relation with the different processes. Now, ang focus natin is the ribosomes. Ribosome is an rRNA protein complex. So, meron siyang rRNA and protein that serves as the site. Siya yung site for the translation phase. Now, what are the features of these ribosomes? Okay, they contain 4 rRNA molecules and 80 protein molecules packed in only 2 rRNA protein subunit. So, may dalawang subunit lang ang ating ribosomes. These are the small subunit and the large subunit. Pero itong dalawang ito, nagko-contain siya ng 4 na rRNA and 80 na protein molecules. Now, each of these subunit, either that is the small or the large subunit, will contain approximately 65% rRNA and 35% protein by mass. So kahit na 80 yan, 35% lang yung kanyang percentage dito sa mga subunits na to. So majority of the subunits in the ribosome are rRNA. Okay. The active site of this ribosome is located at the large ribosomal unit. So yan yung active site niya. Okay, so they are synthesized one at a time. Proteins are synthesized one at a time upon the addition of amino acids to the growing peptide. So, ang active site, kung saan na ilalagay or na ito-transfer yung amino acid at kung saan nag-grow yung amino acids into peptides and peptides into protein ay sa large ribosomal unit. Okay? The active site is mostly rRNA, such that isa lang daw yung protein niya, protein component. And with this, dahil sa predominant ang rRNA, dyan sa active site na large ribosomal subunit, they thought that the ribosome is the enzyme ribozyme. Okay, so because of the percentage of rRNA that could be found in that large ribosomal unit. Okay, and then we also have the small subunit. Kung kanina, ang large subunit or large ribosomal subunit is the active site for this growing peptides or growing amino acids to be a protein. Yung ating small subunit naman, ang ating small subunit, dyan naman pupunta si mRNA so that whatever genetic information it is possessing would be translated to become a protein. So dito na de-decipher sa small subunit na de-decipher yung message ni mRNA or dito na translate. Okay? So ito yung tsura ng ating ribosomes. Sabi natin kanina, meron siyang dalawang subunit. That would be the large and the small subunit. So the small subunit, it is where the mRNA, ito yung mRNA, dyan na translate yung codes or yung mga yung codes or yung mga genetic information na makikita sa mRNA. At yung large subunit naman dyan, so ito yung large subunit, dito naman nangyayari yung pag-transfer ng tRNA ng mga amino acids at dito rin nangyayari yung linkaging ng mga amino acid to grow as peptide and further grow as a protein. Okay? So you have the small subunit, ulitin natin, nandiyan si mRNA, and then the large subunit, dyan naman si tRNA for the protein synthesis. Okay? So we have 5 general steps for this translation process. So una, we have the activation of tRNA. So ma-activate muna si tRNA with the help of an ATP molecule. Ito yung activator niya, adenosine triphosphate. Magfo-form si amino acid. It will then become highly energetic para mak-attach siya dun sa 3' end ng tRNA. Once activated na si in an energetic form and energetic complex si amino acid, it will now be bonded to the 3' end of the tRNA. Of course, with the help of amino acyl tRNA synthetase enzyme, siya ang magli-link dito sa 3' end ng tRNA, ililink niya with the correct amino acid. Okay? So, dapat activated ang ating, with the help of ATP, ma-activate natin si tRNA. Ulitin natin, ang activated tRNA ay merong amino acid na dala-dala dun sa 3' end. Kapag unactivated na siya, wala siyang amino acid dun sa 3' end niya. Only hydroxyl group ang attached sa kanya if it is unactivated. So, for the activation, kailangan natin ng ATP and with the necessary enzymes so that the amino acid will form bond with the tRNA. Now, once this tRNA has been activated, okay, dun naman sa ating small subunit, there would be an initiation. Sabi natin kanina, the small subunit, yan yung place kung saan mag-translate ng genetic information si mRNA. And this will only start if at the P site of the small subunit, ang mai-interpret niya or ang madi-decipher niyang message ay AUG. We know dun sa ating genetic code table na ang AUG codes for not only methionine, rather ito rin ang ating start codon or initiation codon. So once na-detect dun sa small subunit, specifically dun sa P site, ang AUG mag-i-initiate na. So mag-start na ang protein synthesis. The P site is known as the peptidyl site. Okay, so ulitin natin, initiation happens when the P site in the small subunit detects the AUG codon, or that is the start codon. Start codon. Okay, also as the methionine code for the code for methionine. Okay, now once na-detect na, nag-initiate na, okay, may AUG na yan, yung activated tRNA na nagdadala ng methionine, okay, makiki-base pair na siya. So, madedetect na niya. Okay, sa P site may AUG. Yung activated tRNA, pupunta na siya doon sa P site. And paano niya malalaman na siya ang particular na tRNA ang pupunta? Because of the anticodon. So alam natin the anticodon is on base paired with this codon. Okay? So kung kanina may AUG, so maa-attract na yung anticodon na UAC kasi siya yung base pair ng AUG. Okay? So walang T dito kasi walang walang nucleotide na T kasi we are talking about RNA. Okay? Yung T or thymine is only for DNA. Okay? So may UAC. Okay? Now, this UAC tRNA, this activated tRNA with an anticodon of UAC, of course, meron siyang daladalang methionine. Kasi, aside from, yan yung requirement ni AUG. Aside from an initiation codon, it also codes for methionine. Okay? So, after that, ayan, mag-i-interact na siya dito sa P site. So, this interaction will now, so ito na yung large subunit. Kasi sabi natin kanina, the interaction between the mRNA and the there's an interaction between the mRNA and the small subunit. Since nandito na si tRNA, okay, ito naman na dapat nandyan din si large subunit to facilitate the transfer of the amino acid. Okay, so the resulting complex, so ito na yon, with this tRNA present, so the large unit, they need to interact with the large ribosomal subunit to complete the formation of initiation complex. Okay. Now, sabi natin kanina AUG na-detect sa P site ng small subunit, mag-start na yung protein synthesis. And dahil si AUG codes not only for initiation but rather for methionine, lahat ng start ng ating protein synthesis ay amino acid methionine. Okay? So palaging yan yung first amino acid dun sa developing human proteins during this translation process. Okay? So upon the interaction of the tRNA, dapat makiki-interact na rin si large subunit para makomplete na yung process or initiation process. Now, we have the third process, that is the elongation. Elongation, hahaba na. Hahaba na yung mga amino acid or this amino acid chain. Kasi nga, kailangan nating, alam natin that proteins contains at least 40 amino acids in its structure. So, once it has been initiated, okay, at ayan nga, napunta na kanina, sabi natin kanina sa initiation, yung tRNA carrying the methionine will go to the P site, peptidyl site. Okay? So, hawak-hawak niya si methionine. Now, once it was there, nandyan na si tRNA, nag-initiate na, dito sa A site, or this is known as the aminoacyl site. So, peptidyl site, aminoacyl site. The second codon that could be found in the mRNA will be translated this time. So, kung kanina, AUG dun sa first codon, andun na si methionine, okay? Dumating na yung tRNA with methionine. At A site, okay, i-detect naman na yung kung ano ang kanyang amino acid. So, this is GGU and it codes for glycine. So, darating na rin si activated tRNA carrying the amino acid glycine. At makiki-base pair yung kanyang anticodon dito sa codon part ng mRNA. Okay? So, yung amino acid number 2. So this is the second amino acid, binds at the A site. Okay? Now, after that, so meron na tayong dalawang amino acid dito. The next step is these two amino acid will form peptide linkage. Okay, so ito magko-connect na siya dito para kasi nga ang ating proteins ay growing amino acid or long amino acid. So ito na 'yon. A peptide bond will be formed between the first amino acid, methionine, and the second, glycine. And at the same time, marirelease na yung methionine from the first tRNA kasi nga kailangan na niyang makibond with the second amino acid dun sa second tRNA. So, once na nakibind na siya, it forms peptide bond. Okay? Yung ating moves from P site to A site. So, laging tatandaan, the amino acid from the P site will transfer to the A site kasi para mag-form sila ng peptide bond. Now, since wala nang laman itong first tRNA, so syempre, aalis na siya. Okay? Once na umalis na siya, mag-move to the left na itong mRNA. So, kung kanina, ito yung first codon, so wala nang laman yung activated tRNA. Unactivated na siya kasi nag-transfer na dito sa second tRNA. Now, the second codon of the mRNA will now move to the P site. So, from A site naman to P site yung codon natin. Ulitin natin dito yung amino acid transfer from P site to A site. Pero itong codon will now move from right to left. So kung kanina si GGU ay nasa A site, pag nag-form linkage, nag-form ng peptide bond na at ang mga amino acid at natanggal na yung unactivated tRNA, this second codon will now from A will now move to P site. Para yung third codon naman ang itra-translate dito sa A site. So kung ang third codon ay GCU, okay, and that codes for alanine, darating na yung activated tRNA carrying that alanine, and this anticodon will again base pair with the codon. So yung process continuous lang na itutuloy lang, ulit-ulit lang na pag dumating na dito sa A site, yung new activated tRNA, okay, yung itong dalawang amino acid na yan, makikiform siya dito para maging tatlo siya. Once na umalis na itong tRNA dito at empty na itong tRNA na to, aalis na ulit siya. Okay, so the process will continue. So ito na yung makikibond na itong dalawang amino acid dito sa third amino acid, matatanggal na ang empty tRNA, magmo-move na itong amino acid carrying the tRNA carrying the 3 amino acid going to the P site para ito naman ang susunod. So, hanggang sa humaba yung amino acid at ma-form na yung protein. So, repetitive lang yung elongation. So, this elongation continues as the peptide in the P site or the amino acids in the P site will bond with the amino acid in the A site. Okay? Hanggang sa humaba siya. Okay? Now, after elongation, we have termination. Termination will be detected if yung dun sa P site, ang madedetect niya ay a codon that codes for a stop codon. So kung dun sa ribosomal unit dito sa P site, ang madedetect niya ay UAA, UAG, or UGA na alam natin ay stop codon. So, wala nang darating. Okay? So, hypothetical. If on the A site, okay, sorry. So, if this is the small ribosomal subunit and we have the mRNA here with the 5' and 3' ending, then we have the large subunit. Okay, so alam natin this is the P site and the A site. So, dun sa kunyari umalis na yung unactivated, natanggal na yung unactivated tRNA. So, umalis na siya dito. So, yung activated tRNA here, okay, na naka-base pair, tas meron itong mga hawak-hawak na, okay, tanggalin natin to. Okay. So, for this case, kunyari ito, meron na siyang hawak-hawak na iba-ibang amino acid. Mahaba na yung amino acid. If at nag-move na rin siya, nag-shift na rin siya dun sa left. Kung yung susunod na codon codes for UAA and that is stop codon, wala nang activated tRNA na pupunta rito. Kasi nga wala namang lahat ng stop codon, walang tRNA na may hawak ng amino acid niya kasi nga this is already a stop codon. So walang darating na tRNA here. With that, mataterminate na, ma-stop na yung protein synthesis. Okay? Kasi walang darating na activated tRNA. Okay? So ito yung sabi niya, no tRNA has an anticodon that will base pair with the stop codon. Okay? So walang tRNA na makikibase pair with the stop codon. Or with that AA, this stop codon AA, UAA, UAG, and UGA. Okay? And at kapag natapos na, of course, the polypeptide, yung mga chain of amino acid, will be cleaved from the tRNA via hydrolysis. So, matatanggal na rin siya dun sa ribosomal unit niya or matatanggal na rin siya dun sa tRNA. So, ito, polypeptide, which is the chain of amino acids, will be cleaved. So, matatanggal siya from the tRNA in the process of hydrolysis. Now, the last step for translation is the post-translation process. For this, ang nangyari lang dito, there would be some modifications dun sa proteins na na-produce. Ano-ano yung mga modifications na to? Yung methionine, which is the first amino acid in the produced protein, yung iba tinatanggal daw nila. These methionine are in some or in most proteins at yung first amino acid are being removed. And that is through the action of some specialized enzyme via hydrolysis reaction pa rin. So palagi hydrolysis, yung kung kanina yung removal of the peptide from the tRNA is governed by the hydrolysis. Again, methionines removal from the peptide is still hydrolysis. Okay? Tas meron din ito. Second hydrolysis is the release of the polypeptide from the tRNA carrier. Okay. Ano pa yung mga modifications? There are some, okay, if may formation na ng mga disulfides bridges between the cysteine residues. So, yung mga structures ng protein, if you could still remember, the primary, secondary, tertiary, and primary structure of protein, dito na nangyayari yung mga folding, twisting ng mga amino acids or in the protein structure will happen here during the post-translational processing. Pero the folding is not only limited during hindi naman siya nag-start lang sa post-translation, yung mga folding ng mga peptides. Rather, nag-start na siya as the peptides grow as the amino acids form peptide bonds during the elongation process, meron ng mga folding na nangyayari. Kanya lang yung completion ng folding ng mga polypeptides na to also happens during the post-translational processing. Okay? So, bakit kailangan ng folding? Kasi isa yun sa mga properties ng amino acid. Once na na-unraveled yung mga folds ng protein synthesis, ng mga proteins, of course, ma-denature na siya. Okay? So, also during post-translational process, yung quaternary structure, dito rin na a-assemble. Okay?